In today's lesson, we're going to apply properties of logarithms. So there's three main properties of logarithms that we're going to explore. So let m, b, and n be positive numbers such that b is not equal to 1, else it doesn't work. The product property basically states if we have log base b of mn, this could be rewritten as log base b of m plus log base b of n. The quotient property, we're going to be dividing m and n, so thus anything in the denominator we will be using a subtraction sign. So going up here, if we have a plus sign, it's going to be in the numerator, if you will. Finally, we have the power property. And the power property simply states that if I have m to the n power, so log base b of m to the n, then we can rewrite this, or the equivalent statement would be n times log base b of m. If you enter both of those in the calculator, you'll get the same decimal value. So let's apply this. So given that I have log base 3 of 12, which is approximately 12.262, and log base 3 of 2 is approximately 0.631, I want to evaluate the following. So here I have log base 3 of 6, but I notice that I'm not given a log base 3 of 6. So I need to figure out how can I rewrite this so I can use one of my properties to, or which property I can use so that I can use these specific values using 12 and 2. Well, I do know that 12 divided by 2 is 6. So I could rewrite this as log base 3 of 12 divided by 2, which is equal to, so using that quotient property, log base 3, so the 12 goes first, the numerator's first, and then minus log base 3 of 2. So therefore, I would just substitute in those values. Minus, so now it becomes approximately equal to, since we're using those values, 6.3. And when I enter that in my calculator, approximately equal to 1.631. So there's that value. So the next one, I want to do log base 3 of 24, and so again I'm going to figure out, well, which properties can I use to evaluate this one. So I would start off and say, well, I do know that 12 times 2 will give me will work, so I will rewrite this as log base 3 of 12 times 2, which thus can be written as, using that product property, log base 3 of 12 plus log base 3 of 2. Now I can use my approximation values. So thus we would have approximately 2.262 plus 0.631. So when I enter that into my calculator, I get approximately 2.893. So that would be that answer. So this last one, I have log base 3 of 32. When I approach this one, I'm going to say, well, I know that 2 to the 4th power, actually 5th power, wow. So 2 to the 5th power is going to give me 32. So I would rewrite this as log base 3 to the 5th power. So now the exponent goes out in front, and now I have 5 log base 3 of 2. So thus, this is going to be approximately equal to 5 times 0.631, which is approximately 3.155. And I would box in that answer, like so. Now, I do want to warn you about one thing. Since you're listening to this, one thing I'm going to do on the test that I want to make sure that you're using these properties. I'm going to be a little sneaky here, but I'm telling you now so that you know, so that you're not just entering this stuff into the calculator. I'm going to be a little sneaky. I'm going to not give you exact values. I'm going to change this just a little bit. So for instance, I might make this 2.292 or something, so that if you just enter the calculator, it's not going to give you the real, the solution of what I defined it as. So you want to use a solution that I defined it as. So you might want to mark that down. That'll be that's important. Now we're going to use these properties to do something known as an expansion. I want to expand this logarithm using those properties. And when I do an expansion, the order in which I take care of, what to do, I'm going to do like the opposite of order of operations, or order of operations backwards. So the first thing I want to deal with is I'm going to deal with this division. So that's going to be a subtraction. So I'm going to rewrite this as log base 7 of 3x squared minus 5y cubed. And now I'm going to deal with the multiplication and use the product rule. So I'll deal with the 3 and the x squared since I'm multiplying those. Log base 7 of 3 plus log base 7 of x squared minus, and neglected it should be log base 7 there. So log base 7 of 5, and since everything in the denominator we're dividing by, we're going to include a subtraction sign. So that includes the y cubed. So log base 7 of y cubed. So if it's a minus sign, it's in the denominator, and vice versa. And finally, we deal with the exponents. So my final expansion is log base 7 of 3 plus 2 log base 7 of x minus log base 7 of 5 minus 3 log base 7 of y. And we will be using this for other purposes later on, but I just want you to learn how to expand a logarithm. And I want you to be able to do the other side of the coin and condense a logarithm. When we condense a logarithm, we're going to go in the order of operations. So we're going to do that normally. That tells us which ones to do first. So I'm going to take care of the multiplication first, and then I'll deal with the addition subtraction. So now I'm using natural logs. Nothing changes other than my notation. And so now I'm going to have the natural log of 5 squared minus the natural log of 10 minus the natural log of x squared. Okay, now I'm going to work this from left to right. So I'll have the natural log of 8 times 5 squared, and since both of these are subtraction, they both go in the denominator. So I'll have the natural log of 10x squared, or the natural log of, so I'll just combine this into a single log statement. So that's our goal, to combine this into a single log statement. So I'll do 5 squared, which is 25, times 8, which gives me an even 200. And then I'll have 10x squared, and of course I can reduce that, so then I'll have the natural log of 20 over x squared. And so that is condensed and simplified. The next thing I want to discuss is a thing called the change of base formula. Now, if a, b, and c are positive numbers with b not equal to 1, c is not equal to 1, then log base c of a is equal to log base b of a divided by log base b of c. And so we can use this to change to any possible base. Now, this is specifically, good for when you use a calculator that can't use different bases. Now, as the technology updates, we can have calculators where we can change, put in whatever base we want. But by default, most calculators can only handle doing a base of 10 or e. So if you have a base of 7 or 3, then you can't do it. Now, we can also have bases that are variables. And so if we have a base that's a variable, the calculator can't handle it. So if I just log base b, a calculator can't handle that. So we still need to want to know how to use the change of base formula. Plus, we should be able to handle this on a no calculator quiz/test. So that's would be the justification. So let's take a look at an example. So I have log base 6 of 4, and I want to, let's say, change the base to a common logarithm, which is a base of 10. But I could change it to anything. I could change it to a base of 2, a base of 13, a base of 1/2. That's what's cool about the change of base formula. You can do it with anything. But let's do 10. So I'm going to say log base 10 of 4 divided by log base 10 of 6. So notice where the 4 goes and where the 6 goes. And when I evaluate that, I enter that in my calculator. So if you have an older operating system, you'll have to do it this way to calculate the value, and that's going to give me approximately 77.774. So we'll say approximately 0.774. Now let's try with a natural log. So I have log base 6 of 4. So I can write this as ln of 4 over ln of 6 is approximately equal to. So when I type that in, I'll do natural log of 4 divided by the natural log of 6, and I'll press enter. And look at that. Even though I did it with a totally different log, with a different base, I had the same result. And it will work with any base. So that's a really neat thing. So thus we get the same thing, approximately equal 7.774. Anyway, that's how you apply properties of logarithms.